In the highly sophisticated realm of global interior architecture and luxury spatial design, an artisan ceramic wall tile is far more than a basic decorative element designated to cover a structural partition. It represents a living dialogue between organic geological matter and advanced thermodynamics. Structural canvas where raw, filtered water, and volatile thermal currents are harnessed by human hands to construct timeless luxury. To manufacture high-end, three-dimensional embossed ceramic tiles that preserve their geometric precision, vibrant coloration, and material endurance across multiple centuries, a production facility must commit to an absolute standard of engineering right from the initial processing of the soil. This transformative journey from rough earth to architectural masterwork initiates in the controlled parameters of the clay compounding division. The initial phase of this industrial process is defined by strict raw material selectivity. The factory rejects ordinary industrial dirt, deploying only high-purity, premium white kaolin clay and ball clay sourced from specific geological deposits known for their low iron oxide profiles and high structural plasticity. When these raw materials enter the factory stockyard, they undergo a rigorous validation sequence. Senior material scientists execute structural tests to confirm the mineral composition and ensure the total absence of large stone impurities or organic matter that would undermine the firing process later. The raw chunks of kaolin clay are systematically directed into a heavy-duty mechanical hammer mill, where a massive array of high-velocity steel hammers crushes the rugged material, pulverizing it into an ultra-fine, homogeneous mineral powder characterized by an exceptional, uniform particulate scale. The pulverized clay dust is transported via a network of sealed rubber conveyor belts into a high-frequency vibratory separator. This mechanical sieving machine utilizes an ultra-fine structural mesh that vibrates at extreme cycles per minute to isolate and discard any remaining quartz or crystalline sand impurities measuring over 0.5 mm in diameter. Only the absolute purest, cloud-like clay particles are permitted to pass through the screen, entering an automated gravimetric dosing hopper. At this digital junction, a programmable logic controller (PLC) systematically calculates and measures the precise mass of kaolin clay, blending it with metered percentages of pure silica powder and recycled ceramic grout. The inclusion of silica is a vital engineering requirement. It acts as a permanent structural skeleton, regulating thermal expansion and dramatically reducing the shrinkage coefficient of the clay body during the subsequential drying and firing phases. Once the dry mineral matrix is validated by digital load cells, the compounding process shifts from dry preparation to fluid homogenization. High-pressure mist nozzles inject precisely metered volumes of filtered, demineralized groundwater into a massive, heavy-duty industrial stainless steel paddle mixer. The internal steel arms of the mixer engage in a continuous, multi-axis kneading trajectory, aggressively shearing the material to force the water molecules to encapsulate every individual grain of clay dust. This intensive mechanical agitation transforms the dry powder into a rich, dense, uniform gray paste known as plastic clay. The exact water-to-solid ratio is a closely guarded technological secret, monitored via advanced microwave moisture sensors integrated into the mixer walls. If the moisture profile deviates by even a fraction of a percent, the clay will either become too fluid to retain its structural relief pattern during pressing, or too stiff to penetrate the micro crevices of the mold cavity. The transition from the industrial clay compounding division to the semi-automated press molding bay marks the transition of the raw material from a shapeless mass into a highly defined geometric entity. Within this bright, sunlit workspace, the structural design of the tile is established through an absolute synthesis of classic hand-carving techniques and powerful hydraulic force. The walls of the facility are lined with thousands of master plaster and steel dies, featuring intricate, high-definition reliefs that range from classical floral medallions to sharp, contemporary avant-garde tessellations. The creation of a premium tile line begins with an artisan sculptor who spends weeks meticulously carving the original design into a master block of fine-grained plaster using specialized steel chisels and dental tools. This master plaster mold possesses an extraordinary level of detail, capturing delicate texture lines measuring mere microns in depth. Once the design is finalized and approved by the architectural division, the plaster relief is replicated via advanced CNC machining into high-strength tool steel dies capable of enduring repeated cycles of extreme industrial pressure without exhibiting any structural wear or dimensional distortion. The manufacturing sequence initiates as a technician mounts the steel die assembly onto a high-capacity, semi-automated hydraulic molding press. A factory worker takes an aged block of plastic clay from the humidor cellar, slicing it with a wire tool into exact portions calculated to match the precise volume of a single wall tile, such as a standard 10 by 20 cm format. Before placing the clay portion into the open die cavity, the operator applies a micro-thin layer of fine volcanic stone dust onto the steel surfaces. This mineral dust serves as a completely dry, non-toxic release agent, preventing the highly sticky plastic clay from adhering to the micro-textures of the steel die during compression. The worker places the moist clay block into the exact center of the bottom die plate. Instantly, the upper hydraulic ram activates, descending with an engineered force of over 50 tons. A deep, mechanical hydraulic hiss echoes through the bay as the immense pressure forces the plastic clay to behave almost like a high-viscosity liquid, flowing outward and penetrating into every tight, sharp ridge and microscopic crevice of the 3D relief pattern. This intense compression forces the silicate particles into an ultra-dense, interlocking matrix, eliminating any spatial variations and ensuring the structural thickness of the tile is completely uniform across its entire profile. The hydraulic cylinder retains its force momentarily before retracting smoothly, and an integrated mechanical ejector piston built into the foundation of the press lifts the newly formed greenware ceramic tile out of the mold cavity. The transformation is striking. The once shapeless piece of gray earth now displays a crisp, high-definition 3D embossed relief pattern characterized by sharp, symmetrical lines and flawless edges. A craftsman carefully slides a flat wooden paddle beneath the soft tile, lifting it with extreme delicacy. At this unfired greenware stage, the tile is highly vulnerable. The slightest structural imbalance or rough handling would cause immediate warping or fracture the delicate embossed details. The bone-dry ceramic tiles move smoothly along a conveyor line of high-density rubber rollers, transitioning directly into the advanced glazing and surface embellishment department. This sector represents the aesthetic core of the factory, where chemical engineering and classical art merge to give the tile its vibrant color depth, glass-like texture, and permanent resistance to environmental degradation. A ceramic glaze is not an ordinary industrial paint. It is a highly complex aqueous suspension of liquid minerals, metallic oxides, and pulverized glass frit formulated to undergo total vitrification inside the high-temperature kiln. The compounding of the liquid glaze takes place within high-shear chemical blending vats. Chemical engineers utilize digital viscometers and hydrometers to verify that the slurry achieves a perfect specific gravity and an ideal flow rate. The baseline formula contains a balanced mix of silicon to form the glass matrix, alumina to provide structural stability to the molten glass, and various fluxing minerals like feldspar to lower the overall melting point. To achieve rich, luxurious color tones, specific metal oxides are introduced. Cobalt oxide yields deep, royal blues, copper oxide synthesizes vibrant greens or teals, and iron oxide produces warm, earthy terracotta hues. The slurry is agitated continuously to prevent the heavy mineral particles from settling out of suspension. Before receiving their glass-like armor, the dry ceramic tiles pass underneath a localized pneumatic brush assembly that uses high-velocity compressed air to vacuum away any micro-dust or loose clay particles from the embossed surfaces. Cleanliness is a strict engineering requirement during this phase. Any trace of surface dust would create an insulation barrier, causing the glaze to peel or form ugly bald spots known as crawling during the firing process. The dust-free tiles advance immediately into an enclosed, stainless steel airless spray glazing booth. Inside the automated booth, an array of 4 rotating airless spray nozzles atomizes the liquid glaze slurry under intense pressure, creating an ultra-fine, uniform fog of mineral mist. As the tiles pass through this mist on the moving roller belt, The atomized droplets settle evenly across the entire topography of the 3D relief pattern. The fluid dynamic calibration of the spray guns is a critical variable. The glaze layer must achieve an absolute uniform thickness across both the high peaks and the deep valleys of the embossed geometry. If the glaze is applied too thickly, it will pool inside the valleys, obscuring the fine sculpted details. If it is too thin, the peaks will look dry and unvitrified after firing. The glazed tiles travel next underneath a sequence of short-wave infrared drying lamps. The radiant heat instantly evaporates the water carrier from the glaze slurry, transforming the wet coating into